Hello everyone. So in this video, we're going to discuss the CAT 2021 slot 1 QA section. This is a paper that I gave as well, right? So last year, the percentile that I got, I was writing CAT 2021 slot 1. So we'll try to just also recollect what happened while I was writing the exam. I'm doing this in two parts. The first, because 2021 had 22 questions in QA, right? So we'll look at the first 11 questions in the first part of the video, the next 11 in the second part of the video. The idea is when you're attempting a paper which has about 22 questions, you can divide your time into two parts. Try to finish off half the paper in the first part, the second one in the later part, right? This applies to the fact or to a paper where there is a time limit of about 40 minutes. If the time limit goes up to say an hour, then you can actually have 3 or 4 slots ideally of 15 minutes each. Trying to do 1/4 of the paper, say 34 question setup, you can look at 9, 8, 9 in the 4-15 second windows. The other strategy always is to do it in rounds, where you go through the paper once in the first 10 odd minutes, mark a few questions as answers, which you can do orally, and then just mark the question that you want to attempt and go through it. For this paper, I think a good attempt was somewhere around the 8 or 9 question mark. If you had a score in your 20s or early 30s, you would have gotten 90+ percentile in the math section. So yeah, just let's look at this paper and see what happens. Overall, I think the slot 1 paper definitely was not very difficult. Most of the questions were straightforward formula based or basic concept questions, and therefore overall an easy to moderate sort of a paper, I think, right? So let us start. Again, the idea would be to attempt the first 11 questions in about 20 minutes time, so that we and also look at what questions should have been attempted, why a question might have been left in the exam while attempting the paper. So question number 1 says, onion is sold for 5 consecutive months at the rate of 10, 20, 25 and 50 rupees per kg respectively. A family spends a fixed amount of money on onion for each of the first 3 months, and then spends half the amount on onions for each of the next 2 months. The average expense for onions is, so total expense upon total amount upon total weight of onions will be the average expense. So I assume an amount because the amount is same for the first 3 months, and then it becomes half. Also, the number has to be divisible by 10, 20, 25, 25, and 50. So let the amount be say 100. So if the expense has been 100 rupees, what happens is the first month 100 rupees were spent, the second month 100 rupees were spent, third month 100 rupees were spent, fourth month 50 rupees, fifth month 50 rupees. Spends half the amount of onion for each of the next 2 months. Now at 10 rupees per kg, 10 kgs of onion can be bought. At 20 rupees per kg, 5 kgs. At 25 rupees per kg, 4 kgs. And at 25 rupees per kg, here 2 kgs. 50 rupees per kg, 1 kg. So what I'm left with is 300. 400 upon 10, 20, 22. So if it were 400 upon 20, the answer would have been 20. The answer here will be just less than 20. I'm checking for 18, therefore 22 into 18 is nothing but 360 plus 36, 20 into 18, 2 into 18 is 396. This is pretty close to 100, so the approximate answer becomes 18, closest, right? Definitely a doable question, conceptually pretty simple. Then says, Amar, Akbar, Anthony are working on a project, working together. Amar and Akbar can complete a project in 1 year. Akbar, Anthony in 16 months. Anthony and Amar in 2 years. So let us convert the time in months. If the person who is neither the fastest nor the slowest works alone, the time in months he will take to complete the project is. Now the time given is 12 months, 1 year, 16 months and 24 months, 2 years. So I look for the amount of work that is a multiple of 16, 12 and 24. So let the work be of 48 units. Sorry. Right. Now what will happen is when Amar and Akbar are working together, they take 12 months to do the work. So their efficiency will be 4 units per month. 48 upon 12. For Akbar and Anthony, the efficiency will be 48 upon 16, which is 3 units per month. For Anthony and Amar, the efficiency will be 48 upon 2, or rather 24, which is 2 units per month. Now, when the two fastest people work, they will take the least amount of time. When the two slowest people work, they will take the most amount of time. So one is I find out the individual efficiencies of everyone and see who is fastest, who is slowest. If I try to directly figure out, what I can do is, suppose if I look at 1.5, 0.5, 2, 0.5, yeah, so if I just do a bit of hit and trial, 1.5 and 0.5 is 2, 2.5 and 0.5 is 3, 1.5 and 2.5 is 4. So from here I know their efficiencies. The middle value is 1.5, right? And that will be a value that Amar has. So what I'm saying is, the person who is neither the fastest nor the slowest will be a part of the two faster people and the two slower people as well, right? These two are the fastest group, this two is the slowest group. The common person is Amar. So I have to find out Amar's efficiency. What I'm doing is I'm adding all the three. Therefore, twice of Amar plus Akbar plus Anthony will be equal to 4 plus 3, 7 plus 2, 9. Therefore, Amar plus Akbar plus Anthony is nothing but 9 by 2. I subtract Akbar and Anthony from here, right? And therefore, I'll be left with, if I subtract Akbar and Anthony, Amar will come out to 9 by 2 minus 1 in terms, minus 3 in terms of efficiency, which is nothing but 3 by 2. So this will be the efficiency of the person who's neither the fastest nor the slowest, and therefore the amount of time that he will take to do the work will be work upon his efficiency, which will come out to 32 days, the answer. Again, a straightforward question. If you've just gone through time and work, you would have definitely done questions like these. The only catch here was we had to find out the efficiency of one person work for that, and we have to define who that person is, right? Worst case scenario here would be that you find out the individual efficiencies, which again will not take too much time, because the moment you have one value, you can directly find out the other values as well, right? And check which is the person whose efficiency is in the middle, not the fastest, not the slowest. Sorry. Okay. Next, 47. How many 3-digit numbers are greater than 100 and increase by 198 when the 3 digits are arranged in reverse order? Again, if you have done number systems, this is a question that has been asked in previous examinations specifically for 2-digit numbers. So definitely you would have done it. I'm just extending it to 3. In this question, there is a chance of making a mistake because we have to find the number of cases, right? So if this is a question which has options, definitely go for the question. If this is a question which is a fill in the blanks, as it was in this exam, just be sure of your answer. Just make sure you've checked it a couple of times so that you've not made a silly mistake. Now what happens is, since it is a 3-digit number, it will be of the form 100x plus 10y plus z. If I reverse this, it will become 100z plus 10y plus x. And it is said that the difference between these two is 98. So the original number and the new number, the new number increases by 198 and the digits are rearranged. So if I take the difference of these two, it should be equal to 198. The difference here will be 99z, 100z minus z, 10y cancelled, minus 99x, x minus 100x. The difference should be 198 divided by 99. So z minus x should be equal to 2. So from here I can find out the number of cases possible, because the original number is greater than x. X has to be a value that is at least 1. So the number of solutions possible for z and x will be, x being 1 would mean z is 3, 2, 4, 3, 5, a difference of 2, 4, 6, 5, 7, 6879. Beyond this, Z becomes a 2-digit number, which is not possible. So 7 solutions possible for Z and X, right? In that order. How many solutions are possible? So how many numbers are possible? So if I write the number, suppose for any one solution, I will have 1 in front, 3 in the end, and Y in between. How many values can Y take? Y can take any value from 0 to 9. So 10 options for Y. So for every solution for X and Z, I have 10 options for Y. So the total number of solutions becomes 7 into 10, which is 70. For each of the solution here, I have 10 values of Y. So 7 into 10, 70. Again, there is a possibility you might miss out the option value of Y since it is a fill in the blank question. So just check it again. Not a difficult question. Definitely would have done a question which is similar to this in concept, but make sure you've gone through it once to not miss out on the option values for Y. Next says, if the area of a regular hexagon, if a regular hexagon when the diagonals adjoin becomes 6 equilateral triangles, is equal to the area of an equilateral triangle of side 12, the length of each side of the hexagon. Just put in the formula, definitely a question that should be done. The area of a hexagon would be 6 times of root 3 by 4 a square, where a is the side of the hexagon. And the area of this regular hexagon is given equal to the area of an equilateral triangle of side 12. The area of an equilateral triangle with side 12 is root 3 by 4 square of its side. As you can see, the root 3 by 4 gets cancelled. Therefore, 6a square comes out to 12 into 12. So a square is equal to 24, which is nothing but 4 into 6. So if I take the root, a will come out to 2 root 6. You can take as much time as you want to write this calculation. The point is, it's just a one-line question, direct answer. Attempt time would not be more than maybe 30-35 seconds. Small to read, very easy to solve. Just put in the formula and solve. When you're looking at geometry as a topic that you're preparing, make sure you've gone through similar triangles, hexagon, parallelogram, and basics of circle. If there are questions on geometry, one of these topics will definitely be asked. Next, the amount Nita and Geeta together earn in a day equals what Sita alone earns in 6 days. So, if suppose their daily amounts are N, G, and S respectively, I can get one equation. The amount Sita and Nita together earn in a day equals what Geeta alone earns in 2 days. Okay. Again, I have another equation. The ratio of daily earnings of the one who earns the most to that of the one who earns the least is. Suppose their daily earnings are N, G, and S. Again, 2 equations. I'll have to find the ratio between the values because 3 variables, 2 equations. I cannot get a unique solution. Given to me is N plus G. N plus G, Nita plus Geeta, is equal to 6 times of what Sita gets in a day. Amount of Sita and Nita, so S plus N equals what Geeta gets in 2 days. The question is who earns the most, who earns the least. I think even while solving the question, I remember instead of trying to figure out who is earning the least or the most, I simply solved for the ratios and tried to find the answer. What you can do is you can assume one of the values and then solve from there. But again, first I'll remove one of the variables. A clear variable that can be removed is n because the coefficient is same on both sides. So from the first equation, I subtract the second one. Right? So this will give me G minus S is equal to 6S minus 2G, which means 3G will come out to 7S. Right? Now, if we take the value of G as 7, the coefficient of S will come out to 3. I put the values here. G is 7. This is 6 into 3, which is 18. Therefore, N will be 18 minus 7, which is 11. And therefore, the least earning person is S with 3. The most earning person is N with 11. So the ratio becomes 11 is to 3. Right? Straightforward question. Again, And this is not to say that their exact earnings are 11 and 3, but their earnings will be 11x, 7x, and 3x. So the ratio can be found out because 3 variables, 2 equations, a unique solution may not be possible. Will not be possible rather. Question number 50 then. The number of groups of 3 or more distinct numbers that can be chosen from 1, 2, 3, 4, 5, 6, 7, and 8, so that groups always include 3 and 5, while 7 and 8 are never included together is. While doing this question in the exam, I did not read the term together. So I solved it as 7, 8 are never included, and I was very surprised at the simplicity of the question that has been asked in the exam. It was when the solution came out I realized that I'd screwed up. But yeah, hota hai. So always read the question, at least the last line of the question twice, to avoid basic mistakes. But again, this is a question based on selection of distinct objects. If there are n distinct objects, number of selections possible is 2 raised to power n, because every object has an option of being chosen or not chosen. So if there are 5 different balls, each ball has the option of being chosen or not chosen. So 2 options, 2, 2, 2, and 2, they get multiplied, and therefore 2 raised to power 5 selections are possible. The order does not matter here. Right? Whether I take the first ball, this one first or this one first, does not matter. What matters is whether these are being selected or not. So here I have to have groups of 3 or more. So I need at least 3 numbers, and 3 and 5 are always included. So I already have 2 numbers. Right? These are blocked or locked. What I have to ensure is 7 and 8 should not be selected together. So 3 cases are possible. When 7 and 8 are not selected at all. So I'm saying 7, 8 not selected. I'm putting them in a circle. The second case will be 7 is selected for sure, 8 is not selected. The third case would be this is not selected, this is selected. The third case would be 7 is not selected and 8 is selected. Right? In the first case, if 3 and 5 have been selected, 7 and 8 are not being selected. The numbers left with me are 1, 2, 4, 6. 4 numbers are left, and therefore for these 4 numbers, the total number of selections possible are 2 raised to power 4. But in one of these cases, none of the numbers will be selected, which I do not want, because I want at least 3 numbers to be selected. So the number of selections possible here becomes 2 raised to power 4 minus 1, which I had marked as the answer. Here again, 7, 3, and 5 have been selected. So I have 3 numbers. For the rest of the 4 numbers, I may or may not select the number. Therefore, I look at the total number of selections, which will be 2 raised to power 4. And similarly, here I have 3 numbers that have been selected for sure. So for the rest of the 4 numbers, the total number of selections is 2 raised to power 4. There might be a case where none of the 4 numbers is selected, but does not matter. I have 3 numbers with me, so the initial condition is satisfied. Either the first case happens, or the second one, or the third one. So we add the number of cases. Whenever 2 or more things happen together, the number of cases are multiplied, and rule. If one or the other thing is happening, the number of cases are added, or rule. So if I add 32 plus 15, the answer becomes 47. Basic question, unless you end up making a silly mistake. All right. Amal purchases some pens at rupees 8 each. To sell these, he hires an employee at a fixed wage. He sells 100 of these pens at 12 rupees each. Okay, 400 rupees profit. If the remaining pens are sold at 11 rupees each, then he makes a net profit of 300. While he makes a net loss of 300 if the remaining pens are sold for 900 each. The wage of the employee in INR is, okay, number of pens is not given, the wage is not given. Okay. So by selling the first 100 pens, he has already made a profit of 4 rupees per pen. So 400 rupees he already has. If he sells the rest of the pens for 11 rupees, then he will have a profit of 3 rupees per pen. So 3x. Okay. So what I'm saying is, if I just look at the profit part, when he's selling the pen for 12 rupees, the profit will be 4 rupees per pen for 100 pens. So profit is 400. if he sells the remaining pens, suppose the remaining pens are X in number. If he sells the X pens for 11 each, he will have a profit of 3 rupees per pen, therefore plus 3X. From this, we subtract the wage of the employee. This should lead to the profit that he has left within, that is rupees 300. Whereas if he in the second case, if he sells the pen for remaining pens for 9 rupees each, basically a difference of 200 would happen, 2x would happen, and this would be equal to 600. X will come out to 300. 300, 900, 13,000 wage here. So in the second case, he has a profit of rupees 1 per pen. X pens are left, so total profit becomes X. From here, if you remove the wage of the employee, the person will have a loss of 300. So this will be equal to minus 300. I subtract the two. So 2x comes out to 600, which means X is equal to 300. The moment I put this value here, 400 plus 3 into 300, 900, minus W is equal to 300. 1300 minus 300, W will come out to 1000 rupees, the wage of the employee. The point is, see, in the two cases, the difference that he has is, instead of 11 rupees, he is selling the pen for 9. So he has a net loss of 2 rupees per pen. The number of pens sold at the different rate is X, so the loss will be 2X. And overall, the loss goes from a profit of 300 to a loss of 300, so a decrease of 600. So I can directly write 2x is equal to 600, therefore I get x as 300. And then I look at the first equation and solve for w. Again, not a very difficult question, if at all. Definitely should have been attempted. 52 then says the natural numbers are divided into groups as 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Then the sum of the numbers in the 15th group is equal. Now the question is, how many numbers will be there in the 15th group? I just have to look at a pattern here. So again, should be evident, but if you look at the pattern that is given, the first group has 1 number, the second group has 3 numbers, the third group has 5 numbers, and therefore the number of numbers in each group is a successive odd number. What is the sum of odd numbers, n, for the first n odd numbers, the first n odd natural numbers? So the sum is 1 plus 3, which is 4, plus 5, which is 9, plus 7, which is 16. So the sum of the first n odd natural numbers is simply equal to n square. Just 1 plus 3, 4, plus 5, 9, plus 7, 16, and so on. So what this tells me is the last number of each of the group. For example, the last number of the first group is 1, which is 1 square. The last number of the second group is 4, which is 2 square. The last number of the third group is 9, which is 3 square, and so on. We have to find the sum of the numbers in the 15th group. So before the 15th group, the 14th group will end. The last number here will be the square of 14, which is 196. So the 15th group will start from 197, right? It will have again the 15th odd number kind of numbers, and the last number of this group would be 225, square of 15. So we have to find the sum of these terms. Simple arithmetic progression, and therefore the sum could be found out. Now, how many numbers from 197 to 225? How many numbers from 197 to 225? 225 minus 197 plus 1. 97, 98, 99, 200, and then 29 numbers are there. So 29 numbers in an arithmetic progression with common difference of 1, whatever. So the sum of the arithmetic progression will be n by 2 into first plus the last term, 197 plus 225. So this comes out to 29 into 2, 1, 2, 1, 4. 422. So that is 29 into 211. If I look at the options, the last digit should be 9. Only option which has the last digit 9 is 3. So this should be the answer. Again, on the safer side, you might as well multiply. So this will be 211 into 30 minus 1. 29 is 30 minus 1. This becomes 6330 minus 211. 6119 is the answer. Right? If you see the pattern, should happen. If it does not, then I might actually not be able to do it. Question, I missed a question. Okay. Question 53 then. The number of integers n that satisfy the inequalities n minus 60, mod of n minus 60 is less than, mod of n minus 100 is less than mod of n minus 20. What can we do for this question? One is I make cases for the inflection point 60, 120 and solve case by case, or I look at a value using hit and trial and get an answer, or I could try to form graphs and compare the values. I would want to hit and trial and see what happens, because the values are simple, 60, 120 round sort of integers. So let us try to first satisfy the first inequality, that is root of n minus 60 is less than mod of n minus 60 is less than mod of n minus 100. Now if n is a number sorry, which is around 60, n minus 60 will be a very small value, n minus 100 will be a larger value, right? So if I look at the center point between these two values, that is say 80. Now if a number is here, the difference of this number from 60 would be less than the difference of this number from 100, right? And this will be true for anything that is on the left of 60. The difference from 60 will be less than the difference from 100. For anything beyond 80, the difference from 100 will be less than difference from 80. Therefore, for the first equality, everything less than 80 will satisfy the first inequality, right? Then I look at the second inequality, which says n minus 100 mod is less than n minus 20 mod. Again, by a similar logic, I look at the center point of 20 and 100, which would be 60. Any point on the left hand side of 60 will be closer to 20, therefore n minus 20 will be less than n minus 100. We do not want that, therefore we need a point which is towards the right of 60. Anything here will be closer to 100, so n minus 100 will be smaller and it will be farther away from 20. So what I am saying is the right side inequality is satisfied for all numbers greater than 60. If I combine these two, I will get a range of numbers which lies between 60 and 80. How many numbers between 60 and 80? 80 minus 60 minus 1, because 80 and 60 both are not to be included. There is no equality sign, and therefore 19 values are there. Right? Even if you solve the inequality, there is no problem. But I think graphically it becomes a lot easier to solve. Hence, question 53, answer 19. The next question then, logs. So this is traditionally an area where I have struggled, and therefore whenever I get a log question, I try to put in the value. More often than it does not work, and therefore then I try to solve. But in my typical attempts, what I would do is, since I have 20 minutes to attempt 11 questions, I would till now I would have gone in that order. At this point, I would have skipped the question to ensure that maximum number of questions for me are attempted, and then time remaining I would have come to this question, because this is not an area that I'm very comfortable with, right? But since we are trying to solve questions, let us try and solve this one. All right. So what I am able to see here is, there is a 1 plus root of 1 plus x, there is a root of 1 minus x. If I multiply them, there is a root of 1 minus x square. So I start by operating on root on the right hand side. I will not be writing log 10 because the base is same and I don't think we'll have to change the base. So I'm just writing it as a log. On the right hand side, I can say I can take the inverse of it. Therefore, this becomes minus log of root 1 minus x square. 1 minus x square is nothing but 1 minus x, 1 plus x. So this becomes minus log root 1 plus x minus log root 1 minus x. Now I come to the left hand side, which was 5 minus log 1 plus x plus 4 log root 1 minus x. As you can see, these two terms are the same. They will get cancelled out. And therefore, I take the 5. I take this here. So this becomes 5 is equal to negative 5 is equal to minus 4 minus 1. So minus 5 log root 1 minus x. So this would become 5 and 5 cancel. To make the negative, I make it up as 1 is equal to log 1 upon root 1 minus x. Something like this. We will find a value of 100x. So this then becomes 10, right? So because log of 10 will be 1, so 1 upon root 1 minus x is equal to 10, which means root of 1 minus x is equal to 1 by 10. I square both sides. 1 minus x is equal to 1 upon 100, which means x will be 1 minus 1 upon 100, which is 99 upon 100. Thankfully, I think I have the answer, and therefore 100x will be 100 into 99 upon 100, which will give me the value as 99. Again, because I could see that this breaks into these two, I went ahead with the question, or this would have been a question that I would have come to towards the end. Again, because personally I'm not very comfortable with log. Otherwise, not a very difficult question may have been attempted. Question 55 then, this is the 11th question. It reads, if r is a constant such that mod of x square minus 4x minus 3 is equal to r has exactly 3 distinct roots. Now, if you are drawing a graph of a modulus function which has a quadratic inside a modulus, you okay, so basically a modulus, a quadratic looks something like this, right? If I take the mod of it, this is fx. Fx will always be positive, so negative part kind of inverts here, and therefore I'll get a graph which looks something like this, right? Now, for any value of y that I'm or fx that I'm looking at, 3 solutions are possible for only this point. I'll have one solution here, one solution here, one solution here. Anything above this, there will be 2 solutions. Anything below this, there will be 4 solutions, except x is equal to 0. So if I am able to find the value of y at this point, I get the answer. This is where x is 0, right? So what I do is I make it a perfect square first so that it fits this graph. This will become x square minus 4x. Since I need another 4, so I write plus 4 minus 13. This is equal to r. This becomes x minus 2 whole square minus 13 mod is equal to r. Sorry, minus 17. So when x is equal to 2, this will become 0. And therefore r will become 17, because x minus 2, so the graph shifts towards one side. X is equal to 2 will give me a value of 0. The graph kind of shifts towards the left, the rest of it remains same, so the value of r that I require is 17. That's it. You could have solved probably, I don't know, but I think this is the best way to solve, irrespective of where the y-axis lies. we will get the 3 solution point where the normal graph would have had the lowest value. On getting inflected, it gets drawn something like this, and therefore at this point I get 3 solutions, and that is all that I need for an answer. So basically, the minimization problem that we do for a quadratic, I solve it like that. The point at which it gets minimized, I look at the value of fx, and that becomes the answer. Right? Again, a question that could have been attempted. As you can see, we have been able to go through almost 11 questions in about, I think, half an hour. Right? So again, here I was trying to, I was writing all the solutions. I was trying to explain. We talking about the formulas also in between. So this was probably a paper in which you could have attempted 11 questions in 20 minutes, and then hopefully in the next 20 the 11 as well. As far as my attempt goes, which are the questions that I should definitely should have been attempted to ensure a good attempt. Question 45, definitely average question should have been attempted. Question 46, a repeat question. 47, again, let it be for now. Should have been attempted anyways. 48, 45, 46, 48. 49 should have been done, but okay, 49, 4. 50, I got it wrong, so I couldn't count it. 51, I think, should have been attempted, not counting this either. 52, again, may or may not happen. 53, probably should have happened. 54, again, may or may not have happened. Probably 55 should have happened. So what I'm saying is, out of the 11, these could be the 6 questions that should have been attempted. The first 2, gap of 1, the third, and then towards the end, the last 2 or 3 questions, right? Easily could have attempted these questions in 20 minutes. So that is it for this video. We'll talk about the rest of the paper in the next part. Do make sure that you go through that video as well, right? Thank you.